Hello, my name is Dr. Choi. Today we're going to be talking about an instrument called the Polarimeter. This great instrument actually measures the degree of optical rotation that a molecule exhibits by shining light through it. This instrument won't tell you whether you have an R or S isomer, but it will tell you the degree of optical rotation that your molecule will exhibit. Once you put your sample in, you'll take a reading through the vernier scale, and you'll take that reading and plug it into an equation, which we'll discuss later. After you've plugged it into the equation, you'll gain the specific rotation of your molecule. And this is the value that you'll compare to the literature value that you'll look up. Let's take a look at the parts of the polarimeter. First, you have your light source. Notice how it's orange. It's because the lamp is a sodium lamp, and it emits light around the 590 nanometer range. In front of the light is a polarizer, and this is kind of like a filter, where it takes all the light and makes sure only one direction is being beamed through your sample. In the middle is your sample holder, in which you will place your sample. On the other side is the eyepiece, and the eyepiece is kind of neat. It's got two little lenses with which you can use to read the vernier scales. So if you're right-handed or left-handed, doesn't matter. Below that is an adjustment dial, and you may turn it either way. Don't worry about turning it too far. It goes around and around. And of course, you have your on and off switch. You want to make sure that your polarimeter has warmed up for at least 10 minutes to make sure that the sodium lamp is emitting at the highest intensity and the correct wavelength needed to get an accurate reading. Now, let's look at your sample cell. The first is a smaller size, or 1 decimeter in length, 10 centimeters in fact. The second length might be the 2 decimeter, or 20 centimeter length cell. The solvent used is going to be very specific to the compound that you're investigating. You really want to make sure that the solvent chosen is clear and does not have any optical rotation at all. So if it has a chiral center, this is not a solvent you want to use. As well, you want to make sure that the sample that you're looking at dissolves completely in the solvent chosen. Regardless of whether your sample is a solid or liquid, it's got to be able to dissolve in the solvent. Your instructor will probably fill the sample cell for you, and it's hard to not fill it all the way without leaving a little air bubble. But you want to make sure that the air bubble is as small as possible so it doesn't get in the way of the light. As with all instruments, we want to make sure we zero it or calibrate it. Let's begin. First, you want to make sure your sample holder is empty. Next, you'll look in your eyepiece, and there are 3 possible patterns you might see. One pattern might be a rectangle in the middle, which is dark, and 2 squares on the side that'll be light. The other option is that the rectangle in the middle will be light and the squares will be dark. The third option is a completely blank orange screen with no rectangle visible whatsoever. So, take a look into the eyepiece and turn the adjustment dial so that you see completely blank screen. You do not see any rectangle whatsoever. At that point, view the vernier scale. The vernier scale should be at 0. If it's not, alert your instructor, as it may mean that the instrument might need calibrating. Now we're ready to bend some light. Open the sample holder and place your sample cell in the holder. Now you want to make sure that the bulbous part is towards the eyepiece, and if there is an air bubble in the sample cell, make sure the air bubble is caught in the bulbous part. The reason why we want to make sure the air bubble's in the bulbous area is that it prevents the air from getting in the way of the path of the light. Once your sample cell is in the sample holder, we're ready to take a reading. Look into the eyepiece, and as you're looking through the eyepiece, turn the adjustment dial. And what you're trying to get at is that same blank orange screen that you saw previously when you zeroed the instrument. Now at points you may see the rectangle show up, and at times you might see it disappear. Remember, you want it right in the middle where there's no rectangle visible whatsoever. Once you've obtained your blank screen, it's time to take a reading. If you'd like more practice on how to read a vernier scale, consult with your instructor, and he or she will direct you to some extra resources to help you practice and exercise this skill. So, let's now do some number crunching. If your reading is below 90 degrees, then you may use the number as is. However, if you have a reading above 90 degrees, you'll need to do some adjustments. First, take the reading that you have obtained and subtract 180 from your number. Now this might result in a negative number, and that's okay. This number is now your observed angle of rotation. Take this number and you're going to place it in the numerator of the formula. Now the denominator is a little different. You're going to take the path length, or length of your cell, and multiply that by the concentration of the solution in the cell. Remember that the concentration units needs to be grams per milliliter. Take your observed angle, divide by this denominator you've just calculated. This calculated value will be your specific angle of rotation. And this is the number that you'll compare to the literature value that you'll have looked up. The sign of your calculated specific angle of rotation will tell you which isomer you have. A negative number will mean a negative isomer, and a positive specific of rotation will mean you have the positive isomer. When you're done measuring your observed angle of rotation, it's time to take things down. Open the sample holder and carefully remove your sample cell. If you're the last person in lab, turn the instrument off. But if there are other students needing to use the polarimeter, leave it on because the lamp is already warmed up and ready to go.